वेटिंग मध्ये आहे तेवढे घ्या सगळे जॉईन करून.
ऍडमिट ऑल म्हणू की आपण.
ऑटोमॅटिक होते
ऍडमिट ऑल आहे की.
बस ऍड ऑल करून टाका.
सर कुठे गेलो पार्टिसिपंट 52 आलेत की सर. ऍडमिट ऑल म्हणू.
करा
ऍडमिट ऑल. इथलं फक्त आवाज आपल्याला हे करायला लागतोय सर.
करा ते परत राहील.
हे म्यूट केला आणि तुमचं चालू होईल. इथून हे बघा ही तुमचं स्क्रीन. हे बघा ही 5 मिनिटात बघा. ऍडमिट ऑल करून टाका.
आपलं म्यूट केलेलं सगळं साऊंड आवाज जातो ना सगळ्यांना.
इथून नाही जात तुमचं. ही करा ना. अनम्यूट करा. चेक करून
तुम्हाला आवाज येतो नाही अनम्यूट आहे की बस सर. आवाज येतो की माझा आवाज येतो बरोबर. सगळे अनम्यूट केलेत का? सगळे अनम्यूट ॲडमिट आलं. तुमचा आवाज यायला लागला आपल्याला सगळ्यांना.
इथे करायचं म्यूट ऑल म्हणा आणि येस
सगळे म्यूट होतील ना.
हां पण ते स्वतः अनम्यूट होऊ शकतात आता.
ओके.
हॅलो
हॅलो सर. गुड मॉर्निंग सर.
गुड मॉर्निंग. Who is there?
हां बोला सर.
Good morning. Some problem in sharing the file. I don't know what is the way out.
रिसर्च पर्सन
काय करू ॲडमिट हां
आवाज क्लिअर आहे.
किती लोक आहेत?
हॅलो सर. हॅलो हां
हॅलो टेल मी.
सर बोला की पाटील सर बोला. हॅलो. Okay sir. We are resolving that problem sir.
Yeah sure. Yeah you're still not joined na.
काय प्रॉब्लेम.
Net connection is unstable. Net connection problem.
Hello. Please respond somebody.
Yes. Hello sir.
Sir you are saying you are not talking to me at all.
Yes sir.
I have some problem in laptop. Word is not open. PPT is not opening. I am going for my desktop.
Yes.
No, it is not allowing because the people have increased more than 100. It is not allowing me.
Hello sir. Your sound is coming. Yes sir. Your sound is coming sir.
Sir, I want a help. Hello.
Sir.
Can you speak to me? One of you, please.
हॅलो. तुमच्यातलं कोणतरी शिवप्रकाश सरांशी बोला. हॅलो.
Suryavanshi.
हॅलो सर. गुड मॉर्निंग.
How are you?
Fine.
I have a problem in laptop. My PPT is not opening.
एक लक्षात आलं.
My presentation I want on my desktop to open. Please allow them to launch meeting on desktop.
यार पाटील
मला ते म्हणाले डबल आवाज आहे.
Sir, desktop it is not allowing me. Who is the host?
होस्ट इज यार पाटील.
Ask the host to speak to me.
ओके झालं बंद.
बंदच करा YouTube.
हां ठेवा मीटिंग.
आता बोला.
Hello.
Hello.
Sir, your voice is audible, sir.
Yeah, what is not, can you hear me completely?
Yes, sir.
Yes sir.
I have not been able to open my PPT on my laptop.
Okay, sir. 1 minute. One minute. Okay, sir. I'm giving.
Listen to me.
Yes, sir.
I want on the desktop. I will share my file.
Okay.
Desktop is not allowing me to enter. It says the meeting has reached maximum of 100 people. Please try again. Please host. Can they allow me?
Sir, we.
YouTube ला चालू करतो.
No, none of you are listening to me properly.
सरांचं नाव काय?
शिवप्रकाश राव शिवप्रकाश.
काय झालं, प्रॉब्लेम काय?
त्यांना गेला का?
सर हॅलो सर.
त्यांनी अनम्यूट केलंय का? त्यांचा नंबर आहे का सर? फोन नंबर त्यांना फोन करा की तुम्ही अनम्यूट करा म्हणा. आवाज येत नाही ना त्यांचा?
येत होता की आवाज.
हा, मग काय प्रॉब्लेम काय आहे सर? प्रॉब्लेम काय सर आता?
ते डेस्कटॉपला पीपीटी ओपन करतायत.
हा, शेअर केलं पाहिजे.
आपण दिलंय ना शेअर आता.
हा हा.
Hello.
फोन करून बोलूया का?
Hello. Who is the host, please?
सर बोलूया का फोन?
हा.
K.R. Patil. I don't know. Nobody wants to respond. I want to send a file where they can share. No one is helping.
Sir, hello sir. We given you a slide share, sir. You can share from.
I have a problem, Dr. Patil.
Okay. Okay,
Where
sir.
do I send my file? I have a problem in sharing. I will
Okay,
send
sir,
the
okay.
file. Somebody can share. Whom do I send it? Give me address.
सर तुमचा मेल सांगा सरांना.
प्रॉब्लेम समजावून
त्या मेलवरती
मेलवरती
हां
त्यांना काय करायचं?
किंवा व्हॉट्सअपवरती
पाठवायचं का त्यांना?
हां त्यांची पीपीटी घ्या.
हॅलो सर.
Hello.
हा, आर यू गिविंग मेल आय डी?
Yeah, please give. I will send
येस
it.
सर. GBB
1 second.
BB.
GDD.
Yes sir. We are sharing it on WhatsApp sir.
WhatsApp.
हाँ ते टाका. हाँ GBB 1980. करा.
काय करू?
व्हॉट्सअप घ्या त्यांचं सरांचा व्हॉट्सअप घ्या. त्या सरांचा व्हॉट्सअप शिवप्रकाश सरांचा.
Hello.
Yes sir. We are sharing on WhatsApp. हाँ GBB.
No. You can start the function.
Yes sir.
In the meantime, WhatsApp me the email.
Yes sir.
I will send the file.
GBB.
No, you can start the function. Function can
GBB.
start.
Yes sir.
And by
GBB.
that time, we can start. To
या
gain-
फोटो आले बघा. करा शेअर सेंड करा.
सर
Yes sir. Mail is sent on WhatsApp sir.
Yeah. I'm sending. You please start the meeting.
Okay sir. Yes sir.
किंवा व्हॉट्सअपवर टाकलं चालतं.
नाही थांबा ते मेल टाकतील आता आपल्याला. आता मेल ओपन करायला लागला.
त्यामुळे सर तुम्ही बसा.
तुम्ही बसा जरा सर बरं का. हे
बरं आता इंट्रोडक्शन सुरू करायचं कसं करायचं? अजून काहीच नाही प्रॉब्लेम.
अरे हे आता मेल कसं ओपन करायचं?
इथं नाही मेल.
नाही होणार ना.
Patil,
सर you please send your PPT sir.
I'm sending. You start the meeting, sir. Your inauguration, no?
Okay sir. Okay.
In the meantime, I'll send it. Don't worry.
Okay sir. On behalf of the Department of Electronics, Karmavir Bharava Patil Mahavidyalaya Pandharpur, I welcome you all the participants in the webinar IoTs in Electronics Biomedical Instrumentation, organized by Department of Electronics KBP Mahavidyalaya Pandharpur. First of all, I welcome Honorable Dr. Professor Yansi Shivaprakash sir. He is from Indian Institute of Science, Bangalore. I welcome you sir in this webinar on behalf of KBP Mahavidyalaya Pandharpur. Yes, I also.
1 second. I sent
Yes,
the file.
Okay, sir. Okay, sir.
Please, okay, go ahead.
Okay. I also welcome Honorable Dr. S.S. Suryavamshi sir, who is the head Department of Material Science, who is working in Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. So, on behalf of Department of Electronics, KBP Mahavidyalaya Pandharpur, I welcome you, sir. I also welcome the president of this function, principal of our college, Honorable Dr. K.H. Shinde sir. And I also welcome all the participants who are participating in the Zoom meeting. And I would like to tell you, this meeting is also scheduled on the YouTube channel of our college, KBPM Pandharpur Learning Platform. So the participants who are not able to join in the Zoom meeting, they can join with us on the YouTube channel. So once again, I welcome you all in this webinar. And this webinar is now going to start with a Rath song. Sir, I would like to tell you this is a song which is dedicated to our parent institution, Rath Shikshan Sanstha Satara, which is a leading institution in the country who is working for the poorest people and the student. So, with your prior permission, yes, sir.
Please.
Okay, sir. Okay, sir.
Please.
Okay. नाही आधी रे सर मोरे सरांना एकदा बोलूया.
Did you receive my file?
येस सर येस येस आले का मोरे सर 1 minute सर.
Sure.
ओके.
Who is Dr. A.R. Patil?
पाटील सर याच्यात जरा बघून
sir.
How are you? He is the licensing. He is connecting. Thank you, Dr. A.R. Patil. Of course, our main person is Professor Suryavamshi.
Okay, sir.
Still he remembers
Morning,
me.
sir.
I'm so happy.
Morning,
So happy.
good evening, sir.
Good morning, Professor Patil. Thank you.
Good morning.
रहित गीत झाले.
Yeah, please start now. Any technical problem?
No sir. Within 1 minute I'm going to play that song. So ह्याच्यात घेतलंय का रहित गीत?
रेत घेतले वर घेतले डिस्टॉपला जा डिस्टॉपला काही नाही पेंडॉल करा पेंडॉल. हाँ सर हाँ.
येतंय का ऐकू?
रेत घेत आहे काय
येतंय ऐकू येत हां 1 minute. एक मिनिट आले का मोरे सर आले? एकच मिनिट. सर बघा बरं जरा परवासारखं विथ साऊंड राहिलं.
हां
विथ साऊंड राहिलं माझ्याकडनं.
अरे बापरे.
1 मिनिट बघा.
Audio is coming. Don't worry.
कारण
Audio is there.
म्हणून
Audio I am getting.
चालू केलंय का?
हां
बंद करू. स्टॉप शेअर
ओके पुन्हा एकदा
आता करा शेअर.
चालू आहे पण
नाही
बघा.
No, we are hearing.
मग कसं काय बरं करू आहे का परत? हो बाई.
येतो आवाज
हां
येतोय
हां
आवाज येतो
पण दिसते का चित्र दिसते का? चित्र नाही तेच म्हणतो. थांबा तरी थांबा.
अलीकडे घ्या गॅस
वळवा.
स्क्रोल करा.
इकडे उलट जावं आम जावं नाही
ऐकून जात नाही का?
शेअर करू.
हां
गरिबासाठी लेणी मोडून लक्ष्मी वहिनी झाली आई, कमवा आणि शिका मंत्र हा, तरुणाईला प्रेरक होई. स्वावलंबी वृत्ती ठेवून ज्ञान साधना करतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. दलितांसाठी अण्णा तुमची झिजली चंदन काया. अनाथ जीवा सदा लाभली मातृहृदयी तुमची माया. शून्यामधल्या नवसृष्टीचा निर्मिक तोही ठरतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. जीवनातला तिमिर जावा, प्रबोधनाची पहाट व्हावी. इथे लाभले पंखले उनी, उंच भरावी नभात घ्यावी. प्रतिभाशाली बहुजनांचा वेलू गगनी चढतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा.
Thank you, sir. After this Rayat song, I would like to request convener of this webinar, Honorable Professor A.R. Patil, sir, who is working as Head Department of Electronics. Sir, please make your welcome and introductory speech. Honorable Dr. A.R. Patil, sir. आता इथून पुढे गेले.
Good morning to all. Good morning to all. I am Professor A.R. Patil, Head Department of Electronics, Karmevir Bhaurao Patil Mahavidyalay, Pandharpur. I welcome all distinguished participants and my dear friends. In Rayat Shikshan Sanstha's Karmevir Bhaurao Patil Mahavidyalay, Pandharpur, on the occasion of National Webinar on IoTs in Biomedical Instruments organized by Department of Electronics. Especially, I welcome today's resource person, Professor N.C. Shivprakash, Indian Institute of Science, Bangalore. Chief guest, Dr. S.S. Suryavamshi, Head Department of Material Science, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur, and President of this webinar, Dr. K.H. Shinde, Honorable Principal, Karmevir Bhaurao Patil Mahavidyalay, Pandharpur. Instrumentation is the use of measuring instruments to monitor and control process. It is the art and science of measurement and control of process variables within production, laboratory, or manufacturing area Biomedical instrumentation is the field of creating such instruments that help us to measure, record, and transmit data to or from the body. Human body contains various systems such as electrical, mechanical, hydraulic, pneumatic, chemical, thermal, etc. These systems communicate internally with each other and with external environment. Study of these systems and development of related instruments is challenge for us. It is a matter of pride for me to introduce you to the dignitaries who are present for the webinar. For this webinar, we have a resource person, Professor N.C. Shivprakash from Indian Institute of Science, Bangalore. His field of interests are electronic instrumentation, analytical instrumentation, embedded systems, and development of high-pressure DTA and its applications, conducting polymers and organic leads. He completed his BSc and MSc degree from Mysore University. He passed his MSc examination with first rank and got 5 gold medals. He got his PhD degree from the Mysore University. He is a recipient of Young Scientist Award of the Karnataka Association of Advancement of Science. He contributed substantially by publishing and presenting over 170 papers in reputed international and national journals and conferences. He has completed many research and development and consultancy projects funded by DRDO, ISRO, DST, UGC, and CSIR. He is a fellow and member of several professional bodies, including the senior membership of IEEE USA, fellow of Institution of Electronics and Telecommunication Engineers, fellow of Institution of Engineering and Technology. He has been serving as a chairman, member of governing councils, senate, and academic councils of universities and institutions. I welcome you, sir. Now, let me introduce you to the chief guest of today's function. Today we have a chief guest, Dr. S.S. Suryavanshi from Punyashlok Ahilyadevi Holkar Solapur University, Solapur. He has he is head Department of Material Science in the Solapur University. He completed his BSc and MSc degree from Shivaji University, Kolhapur, and also completed his PhD degree from Shivaji University, Kolhapur. He has published more than 200 papers in national and international journals and many minor and major research projects. Under his able guidance, 14 students got PhD and 5 students got MPhil, and now 8 students are working for PhD. He is a BOS member in physics of Solapur University as well as in Shivaji University, Kolhapur. He has got different awards. Some of the awards are Mahatma Jyotirao Phule Award, Lokamangal Shikshan Prasarak Mandals Award, Best Teacher University Award. I welcome you, sir, once again. The president of this function is our beloved principal, Dr. K.H. Shinde, who always inspires and motivates us to organize such events. He has completed his MA in economics in 1983 and MPhil in 1989 and PhD in 1999. 23 students have awarded MPhil and PhD under his able guidance. Now, 4 students are working for a PhD degree. He has published more than 10 reference books and more than 30 research papers in national and international journals. He has completed many major and minor research projects, 1 major and 3 minor research projects. He worked as a lecturer and principal in various colleges of Rayat Shikshan Sanstha, Satara. Also, he worked as a joint secretary of Rayat Shikshan Sanstha during 2005-2008. He is a recipient of Best Principal Award of Pune University. I extend warm welcome to one and all. Thank you once again for all. Thank you.
मॅडम आवाज येईल म्यूट आहे का बघा इथून बसा
Thank you, sir. Thank you so much. Now, may I request to Honorable Dr. S.S. Suryavanshi, sir, Head Department of Material Science, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur, for the inaugural speech. Sir, please, I request you, Dr. S.S. Suryavanshi, sir, please give inaugural speech.
Good morning, everybody. I hope I'm audible to everyone. So, at the outset, I'm thankful to Rayat Shikshan Samstha, Satara, and organizers of KBP Mahavidyalaya for inviting me for today's webinar, which is on IoTs and electronics and biomedical instrumentations under the aegis of RUSA Component 8. So it's a pride that the Rayat Shikshan Samstha has taken a lead to organize a seminar under the aegis of RUSA Component, which is indeed a very good topic. Now, as we have said, the topic is very important, IoTs in electronics, biomedical instrumentation. If you look at the pandemic part which is present, the use of biomedical instrumentation, sensors, and IoT devices is gaining much popularity worldwide regarding the use of sensor, IR temperature sensor, pulse oximetry, and continuous surveillance from thermal cameras. These are the primary applications which are present. When you look forward for the most of useful applications like EEG or ECG, EMG, the commercial electrode with their instrumentation is very costly, and the paradigm is shifting towards affordable healthcare with portable devices is gaining popularity in people like fitness athletes, sports person, and etc. There are several products which are available in the market with leading companies like Apple, Samsung, etc. They have already launched fitness watches with amenities like heartbeat, ECG, and blood pressures, and also SpO2, which is to be measured. The supported softwares comes with the device can record your daily activity and recording the analytics of the above mentioned parameters through Wi-Fi, Bluetooth, connectivity over the cloud in that particular case. Moreover, the research trends for developing new types of sensors which can be reusable, low cost, and high accuracy can be integrated to portable devices. The trend in VLSI or chip design is also taking the lead to way to develop on-chip sensors with processing power and having digital interface like I2C, one wire, SPI, etc. Moreover, the VLSI and chip design is also playing vital role to develop IoT devices like ESP8266, which is a Wi-Fi system, Bluetooth Low Energy BLE, and one important trend which comes under the electronic and particularly the computer science is artificial intelligence and machine learning, which can be useful for early detection of systems or symptoms which are present and analytics which are present. Supposing a person is having a brain cancer in that particular case and you want to detect it through particularly any of these particular concepts which are present, or there is a heart block detection which is possible through ECG and all that, which is important in this particular part. So X-ray analysis for COVID in that particular case, which is present, and other related detections which are present. Now, biomedical instrumentation engineering involves developing new devices and procedures that solve medical and health related problems by combining the recent advances knowledge in engineering, biology, and medicine to improve human health through cross-disciplinary activities that integrate the engineering sciences with the biomedical sciences and clinical practice. Biomedical engineers may spend their days designing electrical circuits and computer software for medical instrumentation. But these are the instruments which may range from large imaging systems such as conventional X-ray, computerized tomography, and magnetic resonance imaging to small implantable devices such as pacemakers, cochlear implants, drug infusion pumps, and some of the prominent biomedical applications include the development of various diagnostic and therapeutic medical devices ranging from commonly equipments like MRI, EEG, regenerative tissue growth, pharmaceutical drugs, therapeutical biologicals, and evolution product is a new model of an existing product that adds new features, improves the technology, and reduces the cost of production. Recent progress on particularly the nanofibers, structures of chitosan, and the biomedical applications in tissue engineering, drug delivery, wound dressing, and antimicrobial are also presented in this particular case. Now, bioengineering field is of service to people which works with living system and apply advanced technology to the complex problems of medical care. Biomedical engineering may be called upon to particularly design instruments and devices to bring together knowledge from many sources to develop new procedures or to carry out research to acquire knowledge needed to solve new problems. It includes one, the acquisition of new knowledge, understanding of living systems through particularly through bioengineering services, the development of new devices, algorithm, process, and systems that advance biology and medicine, improve the medical practice and health delivery, which is present. Now, we also have, in this particular case, the study of biomedical instrumentation can be approached from list of four viewpoints which are present. Techniques of biomedical measurements can be grouped according to the quality that is sensed, such as pressure, flow, or temperature. One advantage of this classification is that it makes different methods for measuring any quantity easy to compare. A second classification scheme uses the principle of transduction, such as resistive, inductive, capacitive, ultrasonic, or electrochemical. Different applications of each principle can be used to strengthen understanding of each concept. Also, new applications can be readily apparent. Measurement techniques can be studied separately for each organ, such as cardiovascular system, pulmonary system, nervous system, endocrine systems. This approach isolates all important measurements for specialties who need to know about specific area, but it results in considerable overlap of quantities sensed and principle of transduction. Finally, biomedical instruments can be classified according to the clinical medicine specialties such as pediatrics, obstetrics, cardiology, and radiology. This approach is valuable for medical personnel who are interested in specialized instruments. Of course, certain measurements such as blood pressure are important to many medical specialties which are present. Now, biomedical engineering leaders are currently challenged by the task of better defining the infrastructure of biomedical engineering, its multidisciplinary nature, and the process employed to educate the new engineers in this changing field. Biomedical engineers of the future will have to be more aware of applicable governmental regulations which set standards for efficacy and safety. If we substitute biomedical engineer for mechanic and technology for handicrafts and mechanical science, we have established the credentials for biomedical engineering of the future, no matter what he or she may do. Thank you very much. Thank you.
Good.
Nice, nice, Professor. Over to MC. Hello.
Hello.
Host should take over. Professor Suryavanshi is
Yeah,
completed.
Yeah.
next.
They have some bandwidth problem. They have some bandwidth
Bandwidth
problem.
problem is there, sir.
Madam.
Okay. Thank you
Next.
so much. Thank you so much, sir. Before we get started, your another resource person speech. Any questions during the presentation? Please type in the chat box your questions. Now, may I request to the resource person, Professor Yansi Shivprakash, sir, Indian Institute of Science, Bangalore, for guiding us on the topic IoTs in electronic biomedical instrumentation. Please, sir, may I request you? Please guide us.
Thank you. Thank you very much. Thank you. Thank you. So, Professor Suryavanshi, Professor A.R. Patil, Professor Shindeji, Principal, faculty members, students, I'm very happy to be with you. After hearing Professor Suryavanshi, there is no need that I should talk.
No, sir.
All of you are hearing?
Yeah.
No. You covered everything where you have not left anything for me. But I presume that there are young faculties, young researchers, young students in the YouTube. So I thought I can just talk about today is the world of IoTs, Internet of Things. If somebody was asking me, what is not Internet of Thinking? Anything that you have in the cyber physical system, you can get connected. So all of you know today, you go to the next slide, please. All of us are going through the pandemic. All
COVID.
are very familiar with COVID.
Opportunity.
So COVID means what?
Create opportunity, victory in disaster. Very nice.
Hello. आवाज येत नाही.
कोणी मारलं? वेगळंच काय आहे तुमचं स्क्रीन दिसेना मला. आतापर्यंत चालू होतं.
Not audible.
लक्ष जायला
Some problem?
Hello?
Hello.
Yeah,
Yes.
please, fine. I will use my mobile. There is some problem.
Okay. Okay.
Oh, sorry. I'm so sorry. Please share the file.
झालं आलं ते मगाशी हे
No, I am
screenच
on my
येत नाही.
mobile. Please share the file, please.
Okay. डॉक्टर
नाही
कांबळे सर.
झालं ते.
डॉक्टर कांबळे शेअर करा पीपीटी. पीपीटी शेअर करा.
Yeah, thank you. Can you hear me, all of you?
Yeah.
Okay. So, today we are all in pandemic. You know that COVID, according to me, is create opportunity for victory in disaster. So that is all COVID. I think we have to create, and I'm sure that in Pandharpur also, Sholapur, Bangalore, everywhere, the situation is same. And BC, AC, all of us are very familiar. Before Christ, after Christ. I want to say today, it is before Corona and after Corona. Next slide, please. So my talk, is I just spent about 2 minutes about what is the role of the teachers, what is science and engineering and technology, what is instrumentation and measurement, biomedical. I have not spent, since all of you are very familiar, I will just spend quickly few minutes on embedded sensors, and finally IoTs and biomedical instrumentation and L center. And I know I'm not going to talk about virtual instrumentation, AI, robotics. So much of technology has changed today. Next slide. So a teacher has got many roles to play. All of you are teachers. Teaching is the primary job. And in addition to teaching, you need to do research. Whatever the little research that we all have to contribute, we should do. And importantly today, mentoring is important. Mentoring, at the situation where students don't have books, don't have any resources, we are all there wherever we are, online teaching. So mentoring is a very important component for the teacher today.
Research, mentoring, reformer, ethical integrity, trained philosopher guide.
So another important, a teacher is a reformer. All of you are hearing me? One of you please respond.
Yes, sir.
Thank you. So a teacher is a reform. Everyone in the country are prepared by the teacher. So integrity, ethics are important. Teacher is a friend. Teacher is a philosopher. Teacher is a guide. All of you kindly mute. There is a disturbance from one of the audience.
Madam. Yes, sir.
All of you kindly mute so that everybody can hear my talk.
To keep
Madam,
the
if
quality
you
of
can-
sound functional during the meeting,
आणि द्यायला
please mute yourself
नाही.
when you are not sharing. Please mute yourself.
please, all of you
त्याला
kindly
लागेल
mute.
मला.
Please, all of you,
मला एक
mute
सांग.
your sound.
तुमचं ऑनलाईन तुम्ही कोणाची फेसबुक देणार आहे? तुम्ही कोणाची फेसबुक देणार आहे? काहून
Madam,
देणार?
kindly,
तुम्ही तर तेवढी वाजवून घेणार आहे ना.
Please mute yourself when you are not sharing. Please.
yeah, next slide, please. So a teacher should have three important qualities according to me. One is humor. Madam, please, those who are not, kindly mute.
Hello. Please mute
Someone should
yourself.
phone her and ask her to mute.
Please mute yourself when you are not sharing. Keep the quality of sound functional during the meeting. Please mute yourself.
No, you have to phone. Somebody should phone. They don't know. They have just switched on all their audio and then giving a talk, giving a lecture. It disturbs. Okay. Teacher should have. Hello. Hello. Can I speak?
Yes, sir. Yes, sir. You can speak.
You just go back. Please go back. A teacher should be. No, somebody still continue to disturb. I don't know what is the problem.
Patil sir, you just take care that somebody is intervening. Mute all the mics.
All the participants are requested to please mute their mics. It is going to disturbing the resource person of today's webinar. I request please mute all the mics.
Sir, please continue.
Hello, sir. Please continue. Hello, sir. Hello. Can you audible me?
So education 1.0 is mere lecturing, teacher centric. Today outcome based education we talk. Sir, you please keep one slide. If you keep on changing, I cannot talk. Why are you changing, sir? Hello. The
Madam.
host who is sharing, can you speak to me? Unmute and speak. If
Hello, sir.
hello, you change when I say. You are changing yourself. The slide. If you are not.
Okay, sir. Okay. I am sharing the slide.
Sir, please go to education 4.0. Yeah, be there. Go. Next slide. Next slide. Next
Yes, sir.
slide.
Yes, sir.
This is over. CV Raman is over. Next.
Next. Okay, sir.
Yeah, please go to the next one.
Yes.
I was telling that scientists are important, engineers are important, technologies are important. Car will come onto the road, only all the three of them together. Next slide. In education, all of you know, first education 1.0 was just lecturing and memorization, but internet changed the whole thing. In education 2.0, the internet and open source have come. In education 3.0, all of us understood knowledge is important. So education 3.0 envisaged the knowledge producing education. And today we have to be innovative as a teachers. So innovation producing education is important. That is where we are. Next slide, please. So in science, always, fundamentally you have to learn. And, what Lord Kelvin said is, when you can measure what you are speaking about and express them in numbers, you know something about it. This is all about the science. You have, therefore, the instrumentation comes into picture. Anything we talk, if we have a mechanism. Understood. Next slide. Since I am going to talk about instrumentation, all of you know instrumentation is dependent on the electronics. So electronics, I will spend 2-3 minutes to tell you how it is evolved. All of you know electronics is a branch of science and engineering. So therefore, in the country, we have MSc electronics, BTech electronics, and so on. And also we are all know current conduction goes through, even conduction takes place through vacuum, gas, semiconductor. So way back in 1799, Coulomb was the first person said there is a charge between the two. If there are two things, then there is a potential, directly proportional to the product of the charge and inversely proportional to the square of the distance. This is the beginning of the electronics. Later, Eirsted in 1820s said current can be produced even in the magnetic field. So therefore, the whole electromagnetic that we study is because of Eirsted. In 1827, Ohm, very great man, he said there is, in an electronic circuit, when there is a current and voltage, current, voltage, and resistance are connected by I equal to V by R, that Ohm's law. And later Volta is a scientist who produced the electricity with a voltaic cell. Next slide, please. So again, Edison is the first man who said that the conduction takes place even in the vacuum. And later, the wireless came. Marconi is a man who invented this, wireless radio. Now today you have AM radio, FM radio. If I carrier wave, if I modulate the carrier wave with the amplitude, is called AM radio. I can hear even from London. I can hear from Australia. But today, FM radio, frequency modulation improves the quality of the signal, but the disadvantage is the longer distance. So these FM, AM radios have all come. And later, Fleming invented the vacuum tube. The first vacuum tube were invented way back in 1904. And one of the Russian, Zovoskin, is a picture tube came. So therefore, TV and all that started coming in 1950, though it came in India very late. Watson invented radar. All of you know radiation detection and ranging. Without radar, there's no fighting between Pakistan and India. The radars are very important. An aircraft which is going, air traffic controller controls everything from the ground. So therefore, radars are an important invention. FM radio came, as I told, and first computer, Mackay, designed in 1946, which is weighing about 10 ton. Very, very big one with vacuum tube. It was occupying 100 meters by 10 meter, such a big, massive computer. Later, all of you know, semiconductors were silicon, germanium. These are invented by Schottky in 1948, and whole 10 ton computer has become in 1960, 10 kg computer. Today we talk about laptop, desktop, laptop, palm top, in your hand you have a computer. So therefore, this is how the integrated circuit, microprocessor, now all of you know today, VLSI, we talk, very large scale integration, nano technology and so on. Next slide, please. So as all of you know, instrumentation is about the basic measurement. Instrumentation, next slide. Instrumentation is, if anybody asks you, there is a difference between instrument and instrumentation. Instrument is what measures. So instrumentation is an area where you measure, you display, you control. These three things happens. So therefore, measurement is very important, because if you want to understand the nature, the instrumentation is very important because material science, electronics, and so on. Every works of engineering requires instrumentation. So electronics plays a major role. Next, control. Instrumentation is about three things. One is measure, display, and control. Next slide, please. So instrumentation, what if you take a salt thermometer, a doctor, which when you go to a hospital, they measure the temperature. The temperature is an instrument, a small instrument where it measures and displays. So that is a very small, minute. Multimeter that you have also measures and display. So, and control, if you go to temperature controller, chemical plant, reactor at Baba Atomic Research Center, Bombay, all the things, if you go to electromagnetic spectra, you have gamma ray, X-ray, ultraviolet, so up to radio frequency. Interaction with the matter, with radiation, gives you lot of information. So this is the beginning of the instrumentation. Next slide. All of you know sensors are very important in measuring. So I will talk about that today's sensors, smart sensors that we call. And all of you must be very clear, familiar with displacement, pressure, temperature, flow, motion, voltage, resistance, current, and therefore, and controlling, as I already mentioned, you use either microprocessor, microcontroller, PC. Today, even embedded systems have come to control because small chip. So in instrumentation, next slide, all of us should be very clear about 3-4 parameters. One, we call it as accuracy. Anything that you do, any instrument, next slide, anything instrument that you develop, you need to worry about accuracy. Unless my thermometer, whether it is giving an absolute temperature or relative temperature, is important. So all of you know the accuracy is nothing but closeness with which the reading approaches. Precision, closeness with which individual measurements are distributed. Another important thing in our instrumentation is error. Error is very important. It could be because of random error, systematic, so many errors are possible due to instrument, due to human. All these, I must tell my instrument that I have developed can measure to what an accuracy, what error associated with my measurement. Linearity is extremely important component in the instrumentation. So all of you know whatever the output that you get versus the measurand. And resolution is, again, if I give a scale of 1 centimeter with 10 division, all of you know that the accuracy is 0.1 centimeter or 1 millimeter. So therefore, the resolution with which we can measure any instrument that we develop, next slide, is it. Another 2-3 important parameter I will just mention and move on. One is repeatability. Any instrument that you develop should be able to repeat. If I do experiment at Sholapur or Bangalore or Delhi, it should give me the result. Even if I go to USA, so the repeatability is important, reliability is important, calibration. Any instrument, if I do, there is a primary calibration and secondary calibration. So therefore, without calibration, if you develop an instrument, that is of no use. So therefore, I thought I should just tell you. Next slide. So when you talk about instrumentation, I told you about sensors. So therefore, we talk about different types of transducer. Basically, transducer, all of you know, is a device which converts one form of the energy into another. If you take a mechanical gauge, dial gauge, it has got accurate, it is quite accurate, low cost, but the demerit is a very frequency, for poor frequency, all frequency it cannot work, and also there are other disadvantages. If you go to electrical, either you measure voltage or current, as all of you know, in electronics, it can be physical, chemical, optical properties. So, but it can amplify, signal that we get in this is very small. So therefore, the sensors, the transducers are basically classified as active and passive. One is self-generating, another one is under the controlling system. Next thing, which I will move on very fast because all of you are very familiar. For displacement, all of you know very well that you use LVDT, linear, variable, differential, transformer. Inductance type, capacitance types are there, potentiometric types are also available. In addition to this, instrumentation, as Dr. Swa, as every one of you know, there are control. The important process control that we do with instrumentation. Basically, we measure pressure, temperature, flow, as Dr. Suryavamshi said. Pressure, all of you know, many things are there, right from, the pressure is all about force per unit area, manometers are there, diaphragms are there. Next slide. So if you go to flow, there are three types, as all of you know: laminar flow, boundary flow, turbulence flow. If you want to measure, there are so many transducers are available. Temperature, I will not get into the detail. RTD, thermistor, and Galileo is the man who first thought that there will be. Next slide. So force and torque. See, I'm going very fast because of two reasons. One, the slides already with I request the organizers to give this slide to all the people who are attending. Optical region, photomultiplier tube, optical isolators, even for the photo emission, photovoltaic. So why I gave all these things? Next slide. Anything that you develop, you need a transducer. So with this transducer, if you can do some signal conditioning, then the whole system, we call it as data acquisition system. There are so many data acquisition systems are available even in the virtual instrumentation. I'm sure that all of you are using national instruments where it allows. So therefore, one part of the instrumentation is measure. The second, if you want to control and then send information. Today, I can control an instrument which is there in New York. So therefore, what I need is communication capability. So the basic thing, all of you know, serial communication, parallel communication. Today, communication, we talk about, satellite communication, even, everything that we do today. Today, I can talk to Americans because through satellites. So mobile communication, cellular communications, and so on. Next slide, please. So therefore, basically, the instrumentation you need is a multidisciplinary area. You can skip this slide. You can go to instrumentation fast. Yeah, thank you. Thank you very much. So device, instrumentation, now all of us understood which monitors and operate instrumentation, is a device, or even, instrumentation we can measure and give you some information. So the sensor is the next slide. I will tell you there are physical quantities that you have to measure. It could be solar heating, freeze, anything that you measure, right from the small thermometer to that, the sensors are there. And if you go to automobile, next slide, you need actuators because you have to move them, you have to make them move, therefore actuators also plays a very major role in instrumentation. It could be of electrical type, it can be of big mechanical pneumatic type, even hydraulic type. So there are three types of actuators which are there in the market. And next important, next slide, component is the stepper motor. Anything that you develop an instrument, if you want to move, in stepwise, in a small step, in a small, small gadget, you need a stepper motor. Most of the small and-on instruments that we do, we use these sensors, transducers, and so synchronous, next slide, is also another important thing. The basically synchronous drive is a two motor thing. One controls the motion. The second one controls the direction, because when you are there in the circular path, the direction is important even in the linear. So these kind of synchronous motors are also available. So moving, the second important part of the instrumentation, as all of you know, is control. Once you measure and display, you need to control. For instance, you take an example of open control. At home, every one of you have a washing machine these days. So washing machine is an open loop control, because there is nothing, all that I have to do is I set the time in the older, there are, of course, the washing machine of very automatic where you need a fuzzy logic. Otherwise, ordinary open machine, I want to know that my 30 minutes, I just want to rinse and then dry it. So therefore, it comes under what is known as open loop. Open loop, it doesn't depend on the feedback. The next slide will show you the closed loop. The example that I can give is simple, is water level indicator. All of you have a overhead tank. If I don't have a water, the a ball valve may fail. So today you can put a level indicator. All that you can do is you say that when the level reaches upper limit, the motor should cut off, and when the water goes lower than the lower limit, it should switch on the motor. All that you do is an on-off control. So this is what we call as a closed loop control, because the input is required whether water level is gone down or. So the fuzzy logic, as I told you today, the modern, next slide, modern instruments will use this fuzzy logic, because PID controls are also is there. But if you want more, PID, as all of you know, the 2 level, it works 0 and 1. In fuzzy, you can have a member set where, neural networks, so many types of controllers have come. So controller is an area by itself. So the example that I can give for a fuzzy logic is today's fully automatic, your washing machine. Next slide. Again, neural network has come a long way in our instrumentation, where we can train some system. So these neural networks are available, knowledge-based computer system or expert system that we talk. Anything that, of course, today we have gone one step ahead, talk about artificial intelligence, robotics. Now the surgeries are done in medical by robot. This, education today, if you want a proctor system exam, artificial intelligence is used. Personalized learning, artificial intelligence using, whether I am learning the coding or not. So these are all some of the development in instrumentation that has taken place. Go to the next slide, please. Next 2 slides you can just skip and then go to Internet of Things. So today, I thought I can speak to you about IoTs in biomedical. Next slide, instrumentation. So therefore, the IoT is nothing but Internet of Things. Everything is internet. I told you that in education industry 4. Industry also has grown. Industry 1.0 was small machine with, run by steam or water. Later in the Second World War, industry 2.0, the railway engine came into being, automation. The third, after the electronics invention, go back. Electronics instrumentation, please don't go till I say go back. Yeah, thank you. In industry 3.0, electronics and IT has made autonomous thing. And fourth, today we are in industry 4.0. Simply industry 4.0 means everything is cyber physical system. Everything can be connected to internet. Even if you are in office, you can control something. If you have not switched out your refrigerator or the lights are on, you can switch it off from your place where you are in the office. So therefore, IoT is very, very expanding area. Today, I just going to share with you some of the IoTs on biomedical instrumentation. Biomedical, which has got a lot of application in pharma and also healthcare, and some example I will give you. And this IoT, lot of startups are coming. So what is, next slide, what is biomedical instrumentation? All of you know biomedical instrumentation is an application of the knowledge and technology to solve the related living biological system. The one biological system is human being. So today, if you go MRI, CT, anything that you do, X-ray is digitized. You can go immediately. Those days have gone by now. If you go to MRI, if you have money, you can scan the whole body. It will tell you the condition. So therefore, human, for instance, if you want, diagnosis and also for cure, in the instrumentation plays a major role. Next slide, please. So, this is a data acquisition system that, a typical one which you can use to measure. If you go to hospital, ECG, all of you know there are electrodes they use and find out the various P, Q, RS, etc. So these are all now computerized. Not only computerized, any information can be sent. What I meant by telemedicine today, if you are your doctor here, earlier we used to go to America for surgery, you don't have to go. The data can be sent right from here, and a surgeon there in America can guide you how to do surgery for an Indian doctor in India. A rural man, if he, a patient can go, need not even go. If you have some facility, a doctor from Bombay can guide. Next slide, please. So therefore, IoT, as all of you know, is nothing but network of physical object. We call things. There are embedded. It could be also it is a sensor, software, and other technologies are embedded inside. So therefore, over internet, this is what we call today in a big word, cyber physical system. Everything we connect with, that is called IoT. Next slide. So therefore, there are multiple technologies in IoT which is done in real time. All of you understand the word real time because there is no point in taking the ticket of the train is left. You have to do the operation before go to the next operation in the closed loop. So therefore, a lot of analytics have been done. Machine learning has come up in the long way. Deep learning is there, where all these things, they have developed a smart sensor, which I'm going to talk to you a little, in a minutes now. And automation is the order of the day. Control systems have come where you can automate it. Now today we talk about smart home. We talk about smart home. Suppose what I mean by smart home is in the evening when the light goes because of the sunlight, you can automatically lights will come. Street light, you don't have to you don't have to go and switch on and switch off. You can set the timer. You can set the intensity of the light. In the winter, it becomes dark earlier than the summer. So therefore, there are smart things have come. So the next slide will tell you about the cyber physical system. So I already told you CPS is nothing but computer system in which the mechanics is controlled or monitored by a computer based on the algorithms. So a cyber physical systems are physical, your system is get connected to a software component and deeply they are intertwined. Next slide. The one example today, I've seen your brochure, all of you have mentioned today pulse oximeter. Next slide. Pulse oximeter is all of you very familiar. It is a wearable things today. As you can see on the screen, one of the finger, there is a sensor and then it reads on the. So pulse oximeter, COVID, especially today, people like to know what is the oxygen level, this saturation, oxygen saturation, we need to know, because if it goes below some number, 92, 1995, then, you have problem. So especially today's context in COVID, it affects quickly. So therefore, they made a very small pulse oximeter. Everyone can afford, you can measure. Patients now, with the COVID also, they can be at home and get isolated. As all of you know, you don't have to go to hospital unless you need a ventilator or ICU. So most of the cases are treated at home. So therefore, this device artificial, arterial oxygen saturation measures and then gives you immediately the reading on the next one. Today, about 2 weeks ago, I was reading in one of the article, they have come long way. A scientist in USA, in Penn State University, and also another Urban Institute of Technology, the two scientists, the Ling Zhang, what they have developed a sensor, a body sensor, which very interesting. They have used a sintering method. Next slide will show you the process. So sintering is a technique by which you can make on your skin. You know that if I go in sintering 600 centigrade, your skin will burn. Even 100 degree you cannot do. So what they have done, even room temperature sintering layers they have done using a polyvinyl alcohol paste. They've used a small air blower In the lab, they have made, next slide, they showed that, the small, whatever I showed, in the skin, they can make this so that it is removable. So that, yeah, thank you. So this sintering they have made on the skin so that your pulse, accelerometer pulse can be done. You don't need even, so the advantage here is even elderly people, even the small children, we have a very small, thin, which is very, very, thin, very sensitive, they also can be made and easy to remove. I am told it takes about an year before it comes to the market. So this is a kind of a thing in the Internet of Things happening. Go to the next slide. Next two slides you can skip. I have explained, and go to IoT future of pharma. Skip this, and next slide. Yeah, thank you very much. All of you know there is a WHO, World Health Organization, and I was hearing a lecture about 3 years ago. World Organization says there are only 36 medicines which are there which can cure any disease. But in India, you know that there are 60 lakh formulas. So the quality check, if you want to do in India, it takes about 2 years. By the time the market, they sell everything, make the money. So they say Baral gun is banned in the newspaper, by then everything is over. So therefore, now we have to go to IoT where things can be made faster. Next one, I give you some examples in the health sector where IoT plays a major. Today, you have a wearing watch. A watch that you wear will tell you the heartbeat, will tell you how many kilometers you are walked, how much of steps you have moved. All these things are there in a watch. So a digital personalized, next slide, a personalized digital appliance have come. You can keep all your health data, any data, next slide, on a palm, a computer like this. Very small gadgets have come. Next slide. The wearable technology is all today, whether it is in a fashion technology, smart wear technology, skin electronics, which I showed you a few minutes ago. It all helps you, thanks to the electronics, to detect, analyze, and transmit the body signal. So this is one example that I've showed you. Go to the next slide, please. So the wearable technology today is gone because of the, this is the powerfulness of the instrumentation. That's what I'm trying to say. So the electronics and instrumentation, today you can wear a watch which will tell you the heart rate, calories burned, steps walked, blood pressure, release of biochemicals, time spent on exercise, seizure, very important. You must have heard a disease called epilepsy, as people will suddenly collapse. So for them, there is a surge of electrical activity in the brain. So such people, if they wear this, immediately they get a notice in the health center and they can be transferred. So physical strength. So therefore, the next slide, so much of development that it has taken. There's another area called cochlear implant. Implant, all of you know. Implant is a neuroplastic device which provides the person to moderate to sensorineural hearing. If somebody has got neural problem, hearing loss, they will use this modified sense of sound, and then they use. I will give an example a little later. So this is an example where all of you know that there are modernized gadgets have come in the canal hearing aids. So though little expensive, but low cost things are also available where impaired people are. Next slide. Yeah, this is an example of that canal hearing aid. Next slide, please. So I will give you some of the examples of IOMT. IoT is Internet of Things. IOMT is Internet of Medical Things, they call these days. They are referred to as smart healthcare. One example that I can give is remote patient monitoring. Today, if the patient need not go to hospital, unless if there's an very emergency, he can be at home, he can be monitored remotely, by suppose isolation wards, because people cannot go to isolation ward like COVID ward, COVID fever ward. So there, this remote patient monitoring helps in a greater way. Next slide. So the medical imaging, as all of you know, has taken a very important role. MRI is magnetic resonance imaging. The nuclear magnetic resonance, all of you know, where the spin the resonance when it takes place, the the spin of the electron, which has got a resonance frequency, which we call Larmor frequency. Apply a field from outside. When they both match, it gets absorbed energy. You get a peak. That will tell you about the the human MRI technology has used this principle, and where brain or any part of the body, if any dislocation, any change can be detected. CTs are there, telemedicine I told you. Now today surgeries are done by artificial. This is all next slide because of the instrumentation. So the future of the pharma, I mean, this is a repetition of the slide. You can move on to the next one where I told you clinical efficiency has gone now. Pathology is an area, you're aware, if you want give a blood test, you can be transmitted through the medicine. You don't have to go there and then collect the data today. So things have been all, the basic science, applied science, electronics, instrumentation, they've all come together in helping. Next slide. The another important area which the instrumentation has played in the medical is voice user interface. You know that there are deafs and dumb, they cannot what they spoken commands are very difficult, so the voice also can be converted and they can be trained. Voice used interfaces are being used in medical system. Can I go to the next one? Next one is all about e-health. Today everything is e-commerce, e-electronics, e-transaction. Everything is, except eating the food, everything is done now through everything e-maya. So healthcare today, because of the internet, because of the instrumentation. Next slide will give an example where you don't, if you give a blood collection also, some people will come home and then collect. You don't have to even go to the diagnostic center. So the message will come onto your mobile showing all the mobile readings. So next slide. This is what I already in advance I told you. So we were in industry 1.0 where small gadgets used to make, and then later after World War, the railway engines came into being. Electronics and instrumentation made the industry 3.0 where autonomous production took place. And today, industry 4.0 expects industrial revolution where everything is cyber physical system. So therefore, I'm very happy that you have organized this seminar. And I'm sure that today, the most of the students whom we train in MSc Electronics and BTech Electronics, they should be aware of this cyber physical system. Okay. So I have another 5 minutes.
Yes, sir. Yes.
Thank you. So embedded system, again, embedded is lot of definition. Next slide. You don't have to, anything that you see is embedded. You go to a computer, there's a keyboard, there will be a microcontroller. You go to a printer, there is a microcontroller. So 80% of the thing that you see in the nature, everything is embedded. So embedded is basically will have the communication capability as well as speed, because CPU should not spend more time. Next slide. So I will not go into the details of this. Microcontrollers are there of various types, 8-bit, 16-bit, 32, and so on. Now any appliance that you see, micro oven, refrigerator, television, a greenhouse, I was telling, environmental control, aerospace, automobile, any area they take. A car has got 12 microcontroller, braking system, air conditioning, and so on. So therefore, these embedded systems plays a huge major role in all walks of life. And aeroplane, it has got thousands of microcontrollers to carry. Next slide. So therefore, these embedded systems finds application in medicine, avionics, space, multimedia, automobile, industry, consumer electronics, telecommunication. Next slide, I will show you some subsystems. So they will also find application in lift control. If you go, there are microcontrollers. Answering machine, go to robot controller, micro oven, engine management. I said car has got plenty of microcontrollers. So this next one will show you another example where process controller, microcontrollers are used, where you can, with your A to D, D to A, you can ask gas flow can be controlled. Next slide will show you a process control, a temperature, typical temperature controller. The next slide will possibly show you the manufacturing system. If you want, a rail system, when you go in a pick and place, robots are also coming in. So therefore, in the next slide, these microcontrollers today, very highly specialized microcontrollers are there, which we call it the digital signal processing. CPU should not spend time. So very versatile DSPs are there. Next slide. Sensors, I've just spent about 2-3 minutes. Having said Spencer, smart sensors are there in the market today. They are intelligent, plug and play. They have automated. They are miniature. They are intelligent and ready. That's why we call smart and reducing cost. And all the sensors that we have today, they have a capability of IoT. IoT concepts have been brought in. The top 10, next slide shows the top 10 trends in the sensor development. One is biosensors, very important in health sector and manufacture. The sector LiDAR, like a radar, the laser is used where automotive and unmanned aerial vehicle UAVs, they use this. Another sensor fusion, large number of sensors are fused together and then very useful in car. I said, for instance, there are 12 sensors can be combined, and then that's an area where automotive is. Another is the fourth sensor trend is advanced driver assistant. Driverless car, autonomous car, electric vehicle, they need this. Smart sensors, I told you, plenty of application in automotive and UAV. The next slide will show you another important 5 areas of sensors. One is called photonic sensors, where image sensors, biophotonic sensors, which are useful in biomedical, even in military application. Gesture recognition, that people which are differently abled, they will not be able to speak. Now gesture, by action, they can say. Wearable things have come, as all of I already showed you. Consumer electronics, automobile, security is very important, and education. The large area sensors have come, which are printed electronics, which I showed you, that sintering technique, consumer electronics and health sector. Energy harvesting, smart building, I told you, industry, healthcare, the last skin, electronic skin, e-skin enabled. The one example I gave you, oximeter, is one example where in consumer electronics, wearable electronics and health sector they use. So this is the trend where we are moving. You move on to the next 2 slides, please, and go to Future India. Hello? Okay. Don't worry. Hello?
Yes, sir. Yes, sir.
Yeah, I will speak. Don't worry about these slides. I just speak in next 2-3 minutes. Future
Okay,
India is made in India, as all of you know, has become make in India. So in future, digital India. So Atmanirbhar India, where now new education policy also says we have to change ourselves with online teaching and so on. And finally, today, last 2 minutes, I want to say there are major technologies which are available, namely artificial intelligence, genetic, 3D printing, augmented reality, autonomous vehicle, hyperloop, smart cities. I'll spend only 2 minutes. Hyperloop is something where you want to go high speed, even higher, more than the aeroplane. About a month ago, I read an article in Japan. They could go in 500 kilometers in 10 minutes. Such the underground, without any distraction, friction, things can move even 1,000 kilometers, 2,000 kilometers per hour. And smart city, I want to say something, because next 100 cities in the India are smart city, where a lot of opportunity for instrumentation, electronics, and even civil engineers, road, good infrastructure, good Mahavidyapit can make some beginning in RUSA grant about startups, and also about the incubation center, innovation center. So I stop here. If you want to achieve, all of us have to work together. Collaboration is important. So I'm sure that all of you come together. And today there are some hurdles, but it went through. I am sorry that there was some problem in network. It's mine or yours. Let us not blame each other. Let us move on. I stop here, and I would like to thank once again Dr. Suryavamshi, Dr. Patil, AR Patil, Dr. Shinde, the principal, and all the faculty members, and all the people who are listening to me, for giving me this opportunity. Sorry, I took up to 1 o'clock because of the initial thing. Hope I try to motivate you, telling that a lot of opportunities are there for both faculty, student, everyone in the area of electronics, in the area of instrument. Thank you all, and over to the Dr. Patil.
Thank you, sir.
Sure. Over to you, madam.
Thank you, sir, for giving your valuable insight on IoTs in electronic biomedical instrumentation. Thank you so much, sir. Now, may I request Honorable Principal Dr. K. Shinde, sir, Principal of Karmevir Bhaurao Patil Mahavidyalaya Pandharpur for President speech. Sir, please give your valuable speech.
My audio was audible for everybody.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, thank you, thank you. I'm very happy. Thank you very much. Yeah, go ahead. Madam, tell Dr. Shinde.
Dr. K. Shinde, sir, may I request you? Please give a valuable speech for us.
Good afternoon, everybody.
Yes.
Good afternoon, Dr. Shinde.
Hi. A national webinar on Internet on Things in Electronic Biomedical Sciences, organized by Department of Electronic Karmavir Bhaurao Patil Mahavidyalaya Pandharpur, which is affiliated to Solapur University. Resource person of this webinar, Honorable Professor N.C. Shivaprakash, Indian Institute of Sciences, Bangalore, and the chief guest of this webinar, Dr. Suryavanshi, Head of the Department of Punya Shlok Ahilyadevi Holkar, Solapur University, and all participants coming from all universities and locations, friends. We all knows that the entire world is facing problem due to COVID-19 corona disease. It is badly affected human life in the past time. The traditional method of use of physicians to diagnose the patients, but these methods are time consuming and varying from result from every physicians. Nowadays, this is a digital age which is useful for all factors. The electronic biomedical instruments are fundamental to successful medical practice. Due to the COVID-19 pandemic period, we all are aware of different electronic biomedical instruments such as the biomedical instruments such as oximeter, electronic thermometer, ECG machine, etc. Biomedical instrument helps physicians to diagnose, to treat, or to monitor patients under medical supervision. And these days, number of patients not going to the COVID center, which is established by civil surgeon, established by some hospitals. They are leave their homes, isolate their homes, and take some medicine by Internet on Things. Due to these features, large patients' data collection becomes possible in this COVID-19 pandemic period. The chief guest, Professor N.C. Suryavanshi, sir, is the HOD of Punya Shlok Ahilyadevi Holkar, Kolhapur University. He explained his views about the IoTs, and definitely it is useful for all the participants. Dr. Suryavanshi, thanks to inaugurate the webinar on, and he is the representative of the university. Dr. Shiva Prakash has nice explained his presentation by number of digital weapons, number of digital which is useful for the COVID-19 pandemic situation. And this is the digital college, digital village, and the concept is digital country. And I highly appreciate your presentation. Therefore, I thank to Dr. Shiva Prakash, I thank to Dr. Suryavanshi sir, and thanks to all of IQAC, Dr. Amar Kamble, Dr. Patil, and all the members who attend the webinar on this situation. Thank you.
Thank you, Dr. Shinde. Thank you very much.
Thank you.
Thank you, sir. Thank you so much for your valuable speech. May I all request to all participants, if you have any questions during this topic, please type in the chat box. Now, may I request to the GB Bhagat sir, please give the vote of thanks of this webinar.
Good afternoon, everyone. Chief guest of today's webinar, Dr. S.S. Suryavanshi sir. Resource person of this webinar, Professor N.C. Shiv Prakash sir. President of today's webinar, our Honorable Principal, Dr. K.H. Shinde sir. Today, the Department of Electronics, Karmayur Bhaurav Patel Mahavidyalaya Pandharpur has organized the national webinar on IoTs in electronic biomedical instrumentation. For this webinar, we have resource person Dr. N.C. Shiv Prakash, who have given us very nice talk on the IoTs in biomedical instrumentation. So I thank Dr. Shiv Prakash sir on behalf of our college. Then chief guest of this webinar, Dr. S.S. Suryavanshi sir, who have inaugurated this webinar and shared his views with us. So I would like to thank Dr. S.S. Suryavanshi sir on behalf of our college and all the participants. Then president of this webinar, principal of our college, Dr. K.H. Shinde sir, who have given presidential address for us. I thank Dr. K.H. Shinde sir on behalf of all the participants. And lastly, I would like to thank all the participants who have participated in this webinar on behalf of our college. So thank you very much. I declare that this webinar is over. Thank you.
Okay. Thank you, Dr.
Thank you, sir. Thank you.
Thank you, Surik.
Thank you, Suryavanshi sir.
Suryavanshi, Dr. Patil, Dr. Shinde, and Madam, and the one who proposed, and every one of you. Very good.
Okay.
All the best. Good luck.
Okay,
good
sir.
luck.
Thank you.
Thank you. Keep safe. Be healthy. And follow
safe.
SMS. Yes is, what is SMS? Sanitizer, mask, and social distancing.
Right. Thank you, sir.
That
This
is a
is
new
the
definition of
essential
SMS.
in the pandemic
Very
situation.
Essential. Thank you. With your kind permission, shall I log out? Sign
Yes,
out?
sir. Yes.
Yes, sir. Yes.
Thank you. Bye-bye. Bye.
Okay, sir. Bye.